For everyone else, very excited to welcome Clarence today. Clarence is an old friend and a classmate from Stanford who's done very well in the field. He has or he's worked at various security startups, and I can just run through. Right, Clarence has worked at he's worked since graduating. He's worked at some great companies in Silicon Valley like Zazzle, Oracle, Shape Security. He authored a book on machine learning and security that's published by O'Reilly. He was a lecturer at Berkeley on security and AI, and most recently and significantly, Clarence has started as a co-founder and CTO of a startup, Unit 21, that is building no-code solutions for risk operations. So B2B, helping companies manage their risk. So very excited to welcome Clarence today. Clarence is a classmate and a good friend and an investor in Rocket Academy as well. Super excited to have Clarence. Thanks, Clarence, for being with us today.
Woo. Yeah, thanks for having me. So I'm happy to share my story and to answer any questions here.
So I was thinking the way we can organize maybe the first 15 minutes or so, we can have Clarence share a bit about Unit 21 or any of the projects that you've worked on and your story as well. And then we can open it up for Q&A. The students can ask the questions that they're most excited about. Is that okay, Clarence?
Yeah, of course.
Okay, perfect.
So maybe I can just start with some quick background. I grew up in Singapore, and I went to school, spent my whole life there, and I came to Stanford for my undergrad. And in Stanford, I studied CS. That's where I first started programming, actually. So I didn't have any prior exposure to any kind of programming whatsoever. And I went to Stanford for electrical engineering, but like many of my peers, decided to switch because of the instant gratification you get from writing code, right? Rather than fabricating some wafers that takes months. Writing code allows you to get that instant results right in front of you. And that was very fulfilling. I think that's what a lot of software engineers like about software engineering as well. At Stanford, I majored in AI. So I spent a lot of my time in AI courses, ML courses. I thought that was one of the quickest ways to get in the future. So ML at the time still was kind of nascent, right? It's just starting to boom. There are some interesting companies, and the large companies, the Facebook and Googles, had just started to really have scaling strategies in machine learning. So I thought that was the future. And I still think that's the future. And throughout the process, I thought there were tons of interesting opportunities. Did a couple internships and decided to go work at a security company. I went to work at a security company just purely out of interest and intrigue. I didn't really have a plan. I just thought that the startup was doing something interesting, and I needed to jump into a startup so I can see how it worked, because I always wanted to start a company on my own. So joining a stealth mode company without really knowing how their technology worked, because they couldn't share it at the time, I just started to figure out what the company was doing after I started to join. And throughout that process, I think I learned a lot. The company was called Shape Security, and I was there for roughly 4 years. The company was acquired a couple of years ago for $1 billion. It was a very interesting experience because I saw a lot of good things about how startups are supposed to be run, and also saw some things that there are indications of how startups are not supposed to be run. So everyone had a really really exciting front row seat into startups. That also kind of gave me enough excitement and learning as a software engineer, but also involved with sales calls and being in front of customers, gave me enough confidence to jump in and start my own company. So after being at Shape Security for 4 years, I left and went to start a company. The company didn't go anywhere. So I think most people probably will share with you that starting companies is really hard and there's a lot of chance involved. So I spent about 9 months just trying out different things and didn't go anywhere. Then I joined I joined a community of similar people in similar stages and met my co-founder, and that's where we started Unit 21. So Unit 21 is a We're a fairly young company, still about 2.5 years old. We have grown quite a bit over the last couple of years. We just raised our Series B round a couple of months ago, and total we've raised about 50 million. The company today is like 90 people. We're we're growing a lot faster than I expected, than I really know what to do with. So there's a lot of constant learning because I think no one really plans for a startup to grow quickly. You kind of look at the statistical odds and understand that, you know, the likelihood is that things will fail, right? And so of course you plan and you hope for some success, some traction, but no matter how hard you work, there's always this very strong element of chance. So this is also my first time growing a software engineering team. We have a team of 55 engineers today. It's a larger team than I've ever led before. Like in my last company, I've only led a team of 3. So it was quite a big jump. And also having worked with some really interesting, some really cool engineers here in my company, I realized that engineering management and software engineering are two very different things, and I like them both. So it was interesting to kind of dive headfirst into both these fields and to learn along the way of what this means, because I never really thought about being an engineering manager, but happy to talk a little bit about what this means as well, because I'm helping some of our teammates through the process. You know, all of the managers in our company are homegrown and are kind of growing into management role from having been individual software engineers from before. So I think this is something that probably everyone, if you spend some time in the software engineering field, you will have to think about and grapple with and decide what you want to do with your career. So happy to share more. Diving a little bit into Unit 21, we're actually not like what a lot of people think we are. So when you go to our website, it looks like we're a fraud company. And so many people think that we do fraud detection. We do some fraud detection, but that's actually not our bread and butter. When I first kind of had the idea for starting a company, I didn't really want to build a company that that was just doing something that companies already were doing. Fraud detection is not a new space at all. There are tons of companies that are very successful in fraud detection. So what I wanted to do was to fill some gaps that there weren't anyone solving problems in. And the specific thing that we're solving for companies is to help operations teams, as in non-engineers, help them to no longer rely on engineers to do their job. And to do that, we built some no-code tools so that these teams can build SQL queries, build data pipelining logic without having to write Spark code, write SQL code, and know what databases are and how they work. Prior to this, the status quo was that these operations teams, who were measured by the amount of fraud they caught, really had to rely on engineers to do their job, which is very unempowering, right? Because the only way they can get better at their jobs was to rely on this other team where there's huge resource contention. Everyone in the company was relying on engineers to do what they needed to get done. And we didn't think this was fair. We didn't think this was the way that it should be. So after talking to a whole bunch of different operators, we found a simple enough way for these teams to make use of software and build logic that can allow them to capture patterns. So the very typical kind of things that we do for companies are, if the operations teams are dealing with fraud investigations or money laundering investigations, which is a lot of what we focus on, then what they would do is to look at patterns of what has happened before. So an example, if you look at a ride-sharing platform like an Uber or a Grab or a Lyft, something that's very interesting to them to capture is abuse promotion. So if there are users that are abusing any of the promotion schemes that they're offering to their customers, let's say you refer a friend and then you get $20. Now it's pretty easy to create a few email accounts and create some fake Uber accounts, and then you can just refer each other. And it's actually not super hard to get around things like that. Uber is not a customer, of course. I'm just using this as an example,
Mm.
but you can make some good money doing this. And so the fraud teams will, of course, be very interested in trying to capture this activity, and maybe want to write queries like, hey, if I want to find all user IPs from Romania who have created Uber accounts and have referred more than 10 people in a 24-hour period, each of these accounts have only taken one ride in the last 7 days, then how do you write a query, right? If you ask me to write a SQL query for this, it would be pretty hard. But how can we allow operations teams to do this, right? If they don't understand SQL, they may not understand the way that data is modeled. What we build is a way for them to use the UI, some drag and drops, some drop downs to create this logic so they can own it, test it, A/B test, back test, validate, deploy, invalidate, and check. That's what we're doing. Today we have about 60 customers and we're growing. So really excited for what the future brings. And still, the vast majority of the work is ahead of us.
Wow. Could you maybe elaborate more also on just for this audience, like the technical, or the way that the team goes about doing technical work? Like, for example, if we were to start on a new project at Uni 21 today, what would be that process of developing that project from end to end?
Yeah, that's a good question. Well, I think it's honestly changed quite a lot since the beginning, right? Because when we were a very small team, let's say when we were like a 5-person engineering team, then the priorities were quite different. At that time, we would maybe have no customers or just one customer, and then the goal would be to just churn something up very quickly to collect data. I think that's a very important thing in an early stage company when you are trying to iterate your way to product market fit. So that's what we did. We didn't bother building things properly, and we just worked as fast as we could to get something to market so that we can validate an idea. So maybe the idea is valid, and then we would just spend more time with our customers, talking to them, being on Slack channels with them and figuring it out. And then we won't care about scaling. We won't care about whether something is built thoughtfully or not, because most of the time it would have to be rebuilt at some point, no matter how much we plan ahead of time. So that's how we did things in the first year and a half. And I think that's the right way to do it. I would do it again, because there's no point in spending a lot of time architecting something for completion when you're not even sure if it's going to be a future for it. So today it's a little different because we have some customers that are relying on our services, our uptime, our software to work. And so it's a little bit harder to say, hey, screw it, I'm just going to build something and put it out there quickly. The move fast, break things slogan doesn't really hold true in a lot of contexts, right? Because maybe it does make sense for a non-critical, social networking website, but for a lot of our customers, they rely on us to be up, and we have to receive transactions, we have to enable transactions to happen. Otherwise, our customers will be stranded in the middle of nowhere trying to swipe their credit card in a gas station, and they'll be stuck for a few hours. So there's some real consequences that can be very clearly measured. And so what we do today is the most common type of project that we undertake, the most common type of thing that we build is something that is product-led. So it's internally driven. Let's say we have this idea for building a link analysis platform, right? So that we can Palantir style try to find similarities between users that are committing fraud. Now, then what we would do is we would have our product team go out and run some validation with our customers to see if is this something that makes sense to them. If so, what are they doing today to fulfill this requirement? And if this is all valid, then what kind of experience would they expect, or what would be ideal for them? Then once we collect these requirements, we would build a product brief or the requirements doc, and then our engineering teams, our engineering managers and leads will go out and start scoping out, building the epics and stories that will back this all up. The whole process can take anywhere from a couple of days if it's something that's really short and urgent, to a couple of months if it's something that is a huge investment of bandwidth, and we will need to put in some meaningful amount of time to figure out if this investment of bandwidth is worth it.
Mm.
So then the engineering teams would split up into pods and parallelize the work. We use somewhat of an agile and Kanban methodology to develop them. So we never really formalized it till recently when we started to realize that there was some friction once the team gets a little bit larger, and also people came from different backgrounds, different levels of rigor of engineering. So many of our folks came from Google, Facebook, who had very rigorous processes, but many of our folks also came from startups, or they were startup founders themselves, and they weren't really used to rigorous software agile development. So having, defaulting to a little bit more of a structure in software development and communication allows for standardization, so that people would have expectations around what they should be doing to document, to communicate, to test, and what level of rigor they needed to go into to ensure that they were doing the job well. The standards were helpful.
Wow, that's super cool. Okay, Clarence, is there anything else you would like to share before we go into Q&A?
Yeah, I think I didn't really talk about the security stuff. I think the security stuff is yeah, no, but the security stuff is I just wanted to say I think security is a super broad field, right? So I wouldn't call myself a security expert or anything like that. I know a lot of great people in security. There are some really interesting. There's a very big security community in Singapore as well that is doing some interesting things. And security is broad. So there's application security, which is almost entirely disjoint from like the network infra security. There's data privacy. There's a whole bunch of different areas over here, all of which we use security to describe it, right? But what security, I think, really is it's a pattern of problems that have to be solved with a way of thinking. So a lot of people think of security as a field where you build things to fight hackers or fight people trying to hack software, and that's actually just a very narrow sliver of security, right? Because more people in security actually work towards building defenses, or building software that helps people gain visibility on security, or finding bugs in software before the hackers do. So I'm happy to dive into some more detail here, but me chancing upon security was a little bit of a happenstance. So I never really planned to go into security. It was just because I joined a security company, and then I realized that security generally is plagued with a lot of snake oil. So there's a lot of vendors that claim to be able to do things that maybe are a little bit magical, or there's things that people don't really understand about security that some of these companies take advantage of, right? And say that, hey, we can solve all security problems, and we can, we're the solution to all your problems. But actually, why I went deeper into using ML and security was because at that time I felt there wasn't really organized material around how to use machine learning in a sane way to solve security problems. And then when looking at all of the ML research that has been done over the past few decades, just like how all software is built, right? No one really built software thinking about security. People didn't really do ML research thinking about security as well. And that's problematic, because when you want to deploy the software, when you want to deploy the machine learning models, then security becomes a real problem, since people rely on this software to make the right decision. And if attackers can influence the decisions in a bad way, then you might not like the outcome. People might die, or there might be bad outcomes. So, yeah, there's all sorts of consequences that people care about.
Awesome. Wow, security is big and broad, and it's not just about hacking. Yeah. Okay, I think we can open up the Q&A. So Clarence, I don't know if you can see it, but there is a pigeonhole. Do you see the pigeonhole link, Clarence, in the Zoom chat? Let me just send it again.
Yes, I did.
Okay, so there is that chat, and the students have been posting questions there, and so I'm just gonna play the role of moderator here and ask some of these top voted questions. I might add some of my own questions too over time, but let's just get started. First question is from Therese. Therese asks, how are startups not supposed to be run?
That's a really interesting question. I think there are a lot of crazy kind of folklore startup stories from Silicon Valley, or in the world, right? Like if you've watched Silicon Valley, the series, then you'll see a lot of examples about crazy startup stories and things like that. Honestly, I think I've heard of examples of bad management in startups, but that is, to be blunt, quite common and also quite understandable. Most startup founders don't think of themselves as great managers. There's not a very strong correlation there, right? So you don't want to do a startup because you want to be a great manager. You want to do a startup because you have this great idea that you want to realize, because you have this dream. You want to do something that doesn't really have a lot of overlap with great management skills. So I know a lot of good startup founders that recognize this early on, and understand that maybe they're not the great manager that they wanted to be, or they're a good manager but they don't really get energy from managing people. Invariably, what's the case is that if you start a company and that takes off even to a small degree, you're still going to have to manage people, and managing people is something that's so crucial to quote unquote running a startup, right? Because that's all that is to it. You have to manage people, manage the business, manage your customers, and all of this is management. So I didn't really think about this when I started the company, and I think I should have, right? I mean, it seems pretty obvious now when we talk about this, but I didn't really think about this. Then I started to think back at all the examples of startups that I've observed that didn't have good management, that treated management as a joke, right? This is very common, right? When you have a large enough company, then people think of management as this jokey thing, like it's not cool to take management seriously. But I think it's actually really important to think about management as a science rather than a very rough thing that you have to trial and error around, because it is a science. There's lots of great books around it, and even though nothing is really transferable, there's no like perfect answer to every situation, but there are some playbooks that you can build your culture around, you can build teams around, that will minimize your chances of doing things wrong. So how startups are not supposed to be run, I think the summary is they're not supposed to be run without thinking about management or talking about management.
Therese, does that answer your question? Yeah. Okay.
Hi, could I piggyback on Therese's
Go ahead. Yeah, go ahead.
Yeah, Clarence, earlier you mentioned you learned a lot from Shape Security on how startups should be run and should not be run. So could you like expand a bit more on what from Shape Security did you really learn, or did you take away, and how you transfer that into your startup, either Unit 21 or the one before that?
Hey, Clarence, I'm not sure. This is recorded, so feel free to give
yeah, of course. Yeah, no, of course. I think Shape Security was honestly quite a well-run company. Like the startup founders had started, I think, 7 companies between the 3 of them, and they were all like successful exits, right? So they knew what they were doing. But still, right, every startup is a little bit different. No matter if you've done it for 3 or 4 or 5 times, there will be some new situations that they're put in front of. One very big thing that I felt myself as an employee in a company was managing morale. And morale is a tricky thing to manage, right? Because when you're running a company, you want to promote equanimity. Like that's the ideal, right? You want everyone to be on an even playing field. You want to be able to share everything, open up your bank account and show how much money you have, how much runway you have. But it's hard to do so, right? There's downsides. So one thing that happened that's I think a pretty clear transition point at my time in Shape was that people, the execs, the sales teams used to share deals, right? They used to share deals on the pipeline. People will be really excited about some of these deals because they're big names and be looking forward to them. And you kind of subconsciously tying the success of the company to the closing of these deals. And when the deals didn't go through, which invariably it will happen. Like, people don't really understand. As a software engineer, you don't understand that 90% of the deals will just fall through when it's expected, right? That's a pretty good number already. And then people would just feel very demoralized. There'll be troughs of people that would leave because a large customer that they've been hyping up for a while didn't go through. And so it made me think a lot more carefully about like what the cost of transparency is, what the cost of equanimity is, and how to balance this. I don't have any answers here, but like it just made me realize that this is really important to think about, because as much as it's important to boost morale and to be transparent, the management of people's feelings without full context of situations is can be pretty harmful if not managed well.
That's your question, Dinesh?
Yeah, that's really interesting actually. Think about transparency versus morale, because you might feel like you're hiding something from your employees if you're not giving them more. Yeah, thanks for that, Clarence.
Yeah,
awesome. Okay, next question is a bit cheeky from Ian. How was Kai like in school?
Man, Kai. So
I don't
Kai
remember.
was like a.
Who remembers this?
So Kai was like an
Not even
intense
important.
person, right? Like my impression of Kai was like he's super intense, right? He's super like committed to something when he wants to do it. And I think it got pretty clear. Like Kai mentioned that I think in the write-up that we ran this half marathon together in our freshman year, and that was peanuts for Kai, right? Because it was challenging for me. But
Clarence is the one who rode like ran like 20 miles a day or something around your house or something.
Yeah, but Kai had run like ultra marathons before, and things like that, right? So I think the kind of intensity translates pretty well to being determined. And I feel like a lot of software engineering is just being determined, right? Like when you're trying to debug something, it's very easy to say, okay, I tried all I can. I'm gonna call it. I'm gonna ask my TA for help, right? But a lot of this debugging stuff is about being structured in your thought and just persevering, because no matter how much you think you can't find the bug, you can. And that was big clear. So I think that's what makes Kai a good engineer. Is like he's smart and he perseveres and determined. So I don't know, man. It sounds like a cop out of an answer, but that was
I'll take
actually
it.
that was actually my impression.
Okay, Ian, does that answer your question? Okay, thanks. Whew, not too bad. All right. Akira's question is, how close are we to the singularity? Akira, maybe you can elaborate a bit on this.
Maybe, I guess it's just a pretty general question. Maybe not everyone knows what the singularity means. Yeah.
What does it mean?
So I guess my general question is just about like what do you think about AI, and Elon Musk thinks that if we're not careful, then it's going to take over the world, and like Terminator 2 and all that kind of stuff. Yeah. I think everyone who practices or knows about AI kind of has a answer about how close are we to AI being super intelligent, and is this direction that everything's going in, or is it all just smoke and mirrors?
Yeah, this is an interesting one. I mean, I think it's definitely very very polarizing, right? There's definitely a camp of people that are AGI maximalists, right? So artificial general intelligence is this idea that, if I'm not wrong, was brought up a few years ago within this camp of singularity that was used to describe whether artificial intelligence can get to a point where it can be a general good problem solving mechanism. Singularity, I think, is this like a hypothetical point in the future where there is some kind of convergence between human intelligence and machine intelligence. To me, frankly, I think we're a long ways away, but then again, I'm proven wrong at every point in time, right? So humans, I think, are pretty bad at projecting exponential growth, and a lot of AI development has been exponential, right? Like you don't expect. I remember a few years ago when I read this paper, there was this paper, security paper that came out of MIT CSAIL, about how they were able to build a model that was able to patch code. And able to patch code is essentially patch security flaws by taking in a bunch of training data from open source code libraries and looking at the issues, looking at the fixes, and then training a model. Very, very standard supervised learning model. And I was blown away by that. I thought, whoa, this is like years beyond what I expected us to be at right now. And then a couple of weeks ago, there was this video about OpenAI's Codex, and I watched it and I was blown away because I thought, well, just a couple of years ago, I was blown away by simple like 2-line code fixes that would potentially endanger the job of software engineers, right? It won't, but that's just the idea that you extrapolate to. But then OpenAI released this library, this tool that allows you to use English to explain what you want the code to do, and then they would generate complicated software to do it. So they were able to build a complete game that you can control with your keyboard in your browser HTML, just by explaining in English what you wanted the program to do. And that to me was very surprising. So honestly, I think when you look at any machine learning algorithms out there, there's a surprising amount that people don't really understand, right? There's a surprising amount that is empirical. So you don't understand how the logic builds up to that. And I think before we are able to uncover a little bit more of that, singularity is probably a bit far out. But who knows, man? I'm proven wrong so many times.
Okay, does that answer your question?
Yeah, thank you.
Awesome. Okay, I think next top voted question is pretty top of mind for folks. Does Unit 21 hire bootcamp grads and/or good bootcamp grads and/or engineers without a CS degree?
Yes, our first software engineering hire was a bootcamp grad, and he was a salesperson. So he was a account executive in a startup for 4 years before this. He went to a bootcamp, joined us as our first engineering hire, and today he's a tech lead, right? He no one can guess that it's his first job. It's crazy. It's like he's performing at the level of someone that has done a few companies before. It's pretty interesting how aptitude and kind of your ability to absorb and learn makes a difference here. We believe a lot in diamonds in the rough. I think software engineering, like some of the best software engineers I know, didn't really go to school for it, and also they were probably really good software engineers before they even went to college. So I think that just goes to prove that the formal CS education is probably helps you to formalize some of the things that you would have learned anyway if you wanted to be a software engineer. And it probably opens some doors for you when you're trying to apply to a job and you don't want to be screened away by recruiters before. But today there's probably a strong enough movement of software engineering, like mid-career switches or people that go to boot camps, people that are self-study, that when our recruiters screen for resumes or screen for candidates, we don't really look for people with pedigree degrees, because I think that means giving up a much broader market of talent that is good engineers and would otherwise have been overlooked by the companies that are still set in their own ways.
And just to
Yeah.
follow up on that, could you elaborate more, like what was so good about this person that you hired that came from a bootcamp? And in general, what do you feel like someone from a bootcamp background could improve on when compared with someone who's coming from a more traditional coding education background?
Yeah. So I think different schools have different methodologies, right? But at at Stanford in particular, I didn't feel like computer science really taught you software engineering. Right? It taught you computer science fundamentals, and there were some classes that required you to write code and, of course, write good code, but it was never really a focus to teach you how to become a good software engineer.
Yeah.
And the real education of knowing, how to work with a team, how software development methodology works, how to think about product development and testing and scalability and robustness came from internships or came from this talking to people that were software engineers.
Yeah.
So I feel like it's kind of weird. There are definitely schools and programs that teach you how to do this. Like I know that famously, like Waterloo and Washington have some good programs that are called software engineering that is actually different from CS. But what in particular that I felt was outstanding about our first hire, his name is Tyler, was that he was just very eager to learn. Right? He's the kind of person that would just say, I don't know what this means. I'm going to commit to it and figure out how to do it. Right. And that kind of energy will naturally bring you towards learning more, because if you're stuck in the deep end of the pool and you have to figure out how to swim or drown, then you will find out how to do it. And there's definitely no lack of resources out there that you can pick up and learn as long as you want to. So he was able to do that. And this was his first job. He really became like a React expert. He's a full stack engineer, and he really dove into the weeds, so much so that when we had more experienced engineers that were working with him, he was able to teach them some things, right? So especially with a field like full stack front-end engineering, where the field develops so quickly, you really have to keep up with what's going on. You really have to know, like in React 14 versus 13, like what is what changed? Like how do you use hooks? Like the best practice from 2 years ago is outdated today. So that sense of wanting to learn more and constantly learning more is really important, and especially so in an area of software engineering like a vertical like full stack front end engineering.
Awesome. Cool. Akira, does that answer your question?
Yeah.
Okay. Joe has a question. In your experience, what are the most common mistakes junior developers make which lead to security issues? How can we avoid them?
Oh man, yeah, I love this question. I think a lot of modern programming languages and frameworks help you to avoid things like that already. So when you're using when you're using non-memory safe languages, right? Like you're using C or C++, then there was a whole class of security issues that would be raised from the potential of buffer overflows or remote code execution where you can move pointers around and things like that. A lot of software engineers probably don't have to think about things like that today, because unless you're programming embedded systems or you're doing something very low level, then it's quite rare that you have to use languages like this or really even think about security issues on that level. The most common mistakes I think come with web programming. Because web is such a wild west still, right? Even after more than a decade of very active focus and development, because there's such a broad range of different browsers and standards and cipher suites and different things that you have to support for the entire world's browsers to be supported, then there's actually a lot of different complexity around web security. I once spoke to someone, like a friend of mine that's is like a god in like web security, right? And he said that 5 years ago, even web security was seen as this lowly field in security. So it was like frowned upon that you work in web security is like you're in a kiddie pool, and the real adults are playing in like, infra security or like, memory programming, things like that. But today is very rapidly changing. Like web security is probably the main vector of attack for most things that you hear about, that you read about in the news. So as a junior developer, I think learning about how some of the most common attacks work, how SQL injections work, cross-site scripting works is really important, because even when using the most modern frameworks, these things happen. So the most common mistakes is probably just not knowing about how some of these work, and then programming a web application that gets breached.
Joe, does that answer your question?
Yep, it does. Since we also covered web security a little bit in the course, it was easier to understand what Clarence was talking about. Yeah, thanks.
Cool.
Yeah, there's this OWASP top 10. That's essentially, I think, the cheat sheet. So if you're going for any security interviews, just make sure you understand the top 10 web application security risks, and you're good, right? So it's like, SQL injection, there's like authentication, there's access controls, misconfiguration, cross-site scripting. So a bunch of these are just really useful to learn.
Awesome. Thanks for sharing. Great. Dinesh has a question. What is the impetus behind no-code tools? What is the difference between a tool and a no-code tool? Which areas do you see as being impacted most by no-code tooling?
I think you answered the first one earlier when you talked about how getting operations people to write SQL queries. But yeah, what's the difference between a tool and a no-code tool?
Yeah, well, no-code tooling is just this very big buzzword right now that people use to raise money. No, so I mean, like, all jokes aside, right? Like, no code, I think, is there's definitely a lot of startups that's using no code to generate buzz right now. I think rightfully so, right? Because you know how I think that there's been a few publications and studies that the world needs more software engineers, and no matter how much we train people to be software engineers to write code, there will still not be enough software engineers to do what we need software engineers for. So the naive way of thinking about it is like, I think in the US there's this thought that you can retrain truck drivers to be software engineers, and the truth is in the vast majority of cases, unless the person really wants to do this, they would not find much success, right? You have to really want to be a software engineer before you can be a software engineer, and a lot of people don't want to be software engineers. So this just means that I think we need to generally find some ways to solve the problem of the lack of software engineering skills. And no-code tools is one of the primary ways of getting there. There's also another buzzword from before that I think is the last generation of this, called RPA, robotic process automation. And that's kind of the last iteration of no-code tooling. It's a little bit different, but same kind of thing. You wanted to build in a layer of automation and software on top of old school tooling. No-code tools started off with very simple things like you can build a website without writing code. That's no code, and that's actually a lot of what no code looks like. So the Canvas, Figmas, some of this is no code, because you don't have to learn how to do web programming before you can make a nice looking website. More recently, I think you see like this no code methodology going into a little bit deeper computer science spaces, like machine learning, like data science, and you can build models without having to write code or understand what the models are doing. And so we're just doing the natural next step of evolution, is like doing data engineering without writing code. Requires you to previously know Spark and EMR and Kafka and Zookeeper, all these things. But realistically, how many people are going to learn these things is definitely not going to be the same number of people that are going to need to know how to use tooling like that and gain the skills. So that's the impetus of no code tools generally, and why we're doing a no code thing.
Dinesh, does that answer your question?
Yeah, and just one follow-up, like how disruptive do you think no-code tools would be, like GitHub Copilot, or what you mentioned earlier with OpenAI, sort of like typing in English and getting a program out? Do you suspect that this will be disruptive in a good way or disruptive in a, I don't know, an odd way?
I think it'll be disruptive in a good way. There's definitely going to be a lot of noise, right? Just like with any buzzword, there's tons of noise. But generally, I think the effective kind of direction of growth is going to be positive, because we need a lot more people to start thinking about what they can do with software, right? And there are a lot of industries that are quite antiquated, that don't really think about how they can leverage software to do their job better, but they should, right? And if they don't think about it, then there are others in their field who will be doing things, like they don't really have a choice. So I think Nocodetools just flattens the playing field a little bit, gives everyone the ability to progress according to how the world is progressing anyway. Specifically in what we're doing, right? Fraud and risk and security never used to be data heavy fields, because security engineers, security analysts were never really statistics people, right? They don't really think of themselves as playing with numbers. They think of themselves as digging into systems, like the kind of hacker cowboy mentality. But now that there's tons of data, the sane way to do their job would be to look at logs, would be to analyze logs, look at metrics, numbers, everything, and they're not used to it. So the only way to kind of progress and to do their jobs without having to scale the number of people in their teams accordingly, or scale efficiency in a less efficient way, would be to use data science, use things that can help them to generate insight without trial and error.
Awesome. Therese, I know you mentioned you might have to leave early, so I want to make sure your questions get asked. Therese had a question, and I think it was briefly covered, but maybe we can follow up just in case. Therese's question is, would you say that there are gaps between industry... Oh, where did it go? Disappeared. Oh, would you say that there are gaps between industry needs and some school curriculums? I know we mentioned that there's computer science is not the same as software engineering before. As a lecturer, what are some of the practices that students adopt to help themselves succeed after graduation? So I know Clarence mentioned internships. Maybe Clarence, you can elaborate. Is there anything else that students can do to boost themselves beyond school curriculums?
Yeah, I think definitely trying to immerse yourself as much as possible in real projects, real software engineering development teams, for as long as you can, is going to be helpful. Because so the class I teach in Berkeley is actually to postgrad people that are looking to use the things that they've learned in security by applying some machine learning to it, right? So it's very much an applied program, and I think there are definitely classes like that in school as well. So optimizing for more applied courses, optimizing for more hands-on development rather than theory will help you to gain more exposure and experience in writing code and building and crafting software. Because the more hours you spend on doing the thing, the better you'll get at it, no matter what the context, right? And then I speak to a lot of bootcamp grads that work on like personal projects. I think personal projects are great, and they help you to figure out something from start to finish, especially if it's driven by personal passion, right? So something that I've always encouraged people that are on the job hunt to do is to find something that you're really interested in solving, that you can kind of think of yourself building a piece of software to solve it, then do it from start to finish. I think that experience frequently, no matter how many times you do it, will help you to learn new things. And I always thought that personal projects were one of the strongest indicators of competence, right? Of aptitude, compared to whatever like Coursera degrees or things that people can get, because personal projects and actually demonstrate a kind of hustle that you can force yourself to do, and it requires perseverance and the attitude to want to learn as well.
Teresa, answer your question? Nice. Okay, awesome. Next question. Wow, this is awesome. There's been a lot of good questions here. Chuan-Xin has a question. I think it's Chuan-Xin's first question. Why the transition from engineer to engineering manager? How vastly different are the concerns and responsibilities of going from an IC to a manager? Are there any anecdotes about what happens to software developers who refuse to become managers?
Yeah, absolutely. I think this is so much on people's minds, right? Like after you spend 5 or 6 years as an engineer, then naturally you'll be, by the peer pressure around you, like everyone that's going on different paths, you start to think about this. And I also thought about this previously. Like I thought that, okay, the way to progress is to become a manager, but that really is the worst reason to want to become a manager, right? Because I think the very successful companies, the FANGs of the world, will make it very clear that you don't have to become a manager just because you want to progress in your field. Career ladders for individual contributors, ICs, and managers are completely different. So you can progress all the way and be a very well-paying, highly respected IC, and you can also be a very well-paying, highly respected manager, and it's just a very different skill set. So I don't think that means that ICs can't be managers. Like, of course, there are really good managers that came from being an IC before, and in fact, most managers probably were ICs before, but they're just very different jobs. So the transition from engineer to engineering manager, I think, mainly comes from the fact that, first of all, in startups, at some point, you will need managers, right? So at some point, I realized that I was managing like 23 people, and I was no longer able to do any work because I was just trying to make sure that everyone had a project to do and following up on the project and making sure that they were happy and they weren't going to leave the company because no one has stopped phoning them in 3 days. And then at some point you're just like looking around, okay, who can help me with this problem? Who will be the person that we can say will make a manager and no one will be surprised, right? I think that's the best way to look for a manager. Is like the people that are naturally already leaders, that are technically respected, that can communicate well and garner action from their peers, are the people that will also not raise any eyebrows or surprise people when you make them managers. And they're also probably the ones that enjoy doing this, because it is not so different from being a tech lead, except that now they have to worry about people's feelings and emotions more so than they did before. So I think it's a very different lifestyle. It's a very different way of measuring your progress as well. All our managers in our company were promoted from ICs, and actually careful not to use the word promoted, because being a manager is not a promotion. It's a role change. And there are many ICs in our company that are paid way better than managers. So we make this very clear in our company, because I don't think there's any pedestal that managers are put on. And we learned this from we learned this from some of the companies that treat management seriously, like in Netflix. Managers are not paid better than ICs, and explicitly so, because when you make an engineer a manager, you are losing a really good software engineer potentially. So you want to be careful about who you're promoting, who you're changing into that role. I keep making this gaffe. Who you're making a manager from the original role, and why you're doing it.
Francine, does that answer your question?
Thank you.
Awesome. Okay, I'm mindful of time. It's 12:56. There are some questions I want to sneak in, so maybe we'll do a bit of rapid fire, Clarence. It's okay. Looking at Unit 21's full stack engineer JDs, what is your team optimizing for as you look for candidates? From Samantha.
So optimizing for, we're looking for great communication. We're looking for people that have experience working with the stack that we're working in, because front end full stack generally quite a sharded, fragmented field. So anyone that has worked with React, TypeScript, JavaScript, we're open to chatting about. And yeah.
Can you elaborate more on communication? You said top things.
Yeah. Communication is, I think, really important and frequently underrated, especially in smaller teams where a lot of the responsibility of asking questions is on you. So unlike bigger companies where generally I think there's a little bit more structure and a safety net for making sure that people are clear and there's a very strong network of support and mentorship. In smaller companies and startups, generally, if you don't know something and you don't say anything, no one will know that you don't know something. So communication is really important because we are relying on people to say something or to ask questions or to ask for help whenever they need it, and also to be able to share their ideas and to present their work, explain their thoughts and their reasoning behind something, because everything moves generally at a much faster pace. And if we wait, or if people are quiet or silent or don't want to be involved with discussions, then it just slows everything down tremendously.
All right, Sam, does that answer your question? Okay, real quick, Porter had a question. I think this is the last question from the students. What are the key difference between software engineering and cybersecurity?
Key difference between software engineering and cybersecurity. I think that there are a lot of security engineers that don't consider themselves software engineers, and that's because they don't really write code, right? So when I think of software engineers, they write code, build features, and focus on the functionality of the product. In security, there are many roles in security. So I'll talk about security engineers, and I'll also talk about penetration testers, which I think is another very common type of role. Security engineers are more security generalists. So some of them are software engineers, as in they build features that are security centric. So for an example, a security engineer at Airbnb would be in charge of building the authentication portals or the permissions portals. Whereas a security engineer at, let's say, a security company might be involved with building the data processing pipeline for parsing logs that they get from servers to find malicious activity. So that's I think the most common thing, where you're judged not by the features that you build, but by the completion and safety and security it brings to the platform. Penetration testers, just quickly, is a field where you don't write code, you don't build features. Well, you don't write production code, you don't build features, but your entire job is to figure out how to break the software. And it's a really fun job if you have a lot of patience. So the best penetration testers I know are just like, they never sleep, and they know the code base better than the people who wrote the code. So only then are you able to find bugs and issues that the people who write the code miss. And then they are paid handsomely. Some of the penetration testers earn millions of dollars a year just by submitting bugs to big companies.
Awesome. That was great. All right. Unfortunately, we're out of time. Clarence, last question. Would you have any final advice for our grads as they embark on this journey?
I think final advice, I think it's awesome that you guys are in Rocket Academy. The well-roundedness of the program, I think is great, right? Because being a software engineer is a lot more than just writing code. You can learn how to write code from a whole bunch of different places online without being in a community like this. And so my biggest piece of advice is to continue being a well-rounded engineer and learning a lot more than just algorithms and how to write software, because that will help you to become correspondingly a more well-rounded software engineer.
Thank you so much. It's so great. Thanks so much, Clarence.
Yeah, thanks Kaya. Thanks team for having me here.
Okay.
Cool.
Okay.
Okay. See you all.
See you.
Bye.
Have a good day, guys. Thank you.